Welcome to the Windward Service Reliability Demonstration utilizing ServiceNow SRO. First, a quick review of the components and functions for this demonstration. We'll be utilizing GitHub as our DevOps repository for both the application code as well as our observability as code definitions. Jenkins is our build pipeline, which executes our observability configuration changes and deploys our application. Dynatrace, a leading APM tool, will be measuring the SLI values. ServiceNow SRO will be consuming the SLI information and measuring against the defined SLO. Both Dynatrace and ServiceNow will consume data from the GitHub repository, which will be enabled through the Jenkins pipeline. ServiceNow could be further utilized to manage the lifecycle of the CI and incident through additional modules not in today's demo. During this demonstration, we'll be showing the setup process, execution of the SLO as code, and finally the results when an issue occurs. Starting with our setup process, with creating the ITOM event management and Dynatrace integration, reviewing the application service definition within the SRO workspace, which was created earlier, followed by reviewing the build pipeline that brings everything together. During the execution, we'll see the SLI being created within Dynatrace, followed by the matching SLO within ServiceNow. Our final step will be viewing the results of an SLI breach, starting with Dynatrace and following through to the SLO impact within ServiceNow. Now let's get started. To start, we need to look at our push connectors and find the Dynatrace monitor push connector. We need to ensure that this connector has been installed and is active. You can see as part of this push connector's information, it gives us the webhook URL to specify in Dynatrace. In addition, the JSON body payload format has been provided. Now, let's take a look in our SO workspace at the application service, which we've created in preparation for this demo. This step takes several minutes, so we've done it ahead of time. We've related business criticality, operational status, and environments to the service as part of the configuration. In addition, we've set myself as the owner, and we've also set a support group. On the Integrations tab, we've created the integration for Easy Travel. You can see it's connected to the Dynatrace push connector and pointing to the Easy Travel service. We must also go to Data Processors and select our Dynatrace data processor. We've already modified it to remove the option to require a name patch as part of the SLI event processing. By doing this, we have better control over which events are used to impact the SLOs of an application service. To further identify which events are used to match SLOs, we've already defined a custom event type value called SLI. We will be using this value during our next step. For our last step of ServiceNow preparation, we need to create an ITOM event rule. We've already created an event rule, and it's called Windward Dynatrace SLI definition. If we select this rule, we can see that we've set the order to 200 and given it a useful description. Our filter is looking for the flattened piece of information from Dynatrace JSON payload that is very specific and also a custom identifier, which we've added to the Dynatrace metric event. Under Transform, we set the event type to SLI, the value we created earlier. Then under the resource, we identify the flattened JSON value that was used earlier as a filter. This will be the glue to tie our Dynatrace event to the correct SRO SLO. There are no other modifications to the regular event processing within this rule. Now we can begin our Dynatrace configuration. First, we'll start with the settings menu and then to the alerting box, followed by a problem alerting profiles menu option. You can see that we've already created a profile called SLO Easy Travel Front End. Viewing the content of this alerting profile, we can see that the filter is looking for custom events whose title begins with SLO Easy Travel. This is important because our automation process will create an event later which utilizes this naming pattern as part of its name. Once our alerting profile has been created, we can create our integration for problems. Here you'll see we've already created an easy travel integration. Expanded, we can see it's utilizing a custom webhook function of Dynatrace. The URL is provided to us earlier by ServiceNow and is specific to the application service we created the SLO integration for. ServiceNow requires authentication for the web service, and this is where we've provided the credentials to write to ITOM REST web service. The body of the event was also provided to us earlier when we reviewed the push connector. The final value that we've had to set is to associate this integration with the alerting profile that we created previously. I would like to go through some of the configuration files that are required for the operation of this project. We are looking at the contents of our K23 Easy Travel GitHub repository within VS Code. You'll see our .monaco directory contains our project directory of K23 with a directory for SLO definitions and metric events. Contained within those are the YAML files, which define the individual elements, as well as the JSON files, which are used to populate the calls that get sent to Dynatrace by the Monaco component. We also have our manifest file defining our connection to Dynatrace, and our ServiceNow YAML file, which defines our connection to ServiceNow. Outside of the .monaco and the .servicenow files, we have the other items which would be modified through this Git repo on our application. Here we're looking at our Jenkins automation, which ties everything together. So we've got our pipeline, Easy Travel, and we'll take a look at our configuration quickly. Our configuration is contained within the pipeline script. Pipeline script has multiple stages to obtain our Git repo, to deploy Monaco based upon the Git repo, to execute our ServiceNow SRO integration, and then to perform the application deployment tasks. So this is a very simple pipeline to simulate what an application deployment pipeline would look like with the addition of our Monaco and ServiceNow SRO additions. Now let's bring it all together by executing our pipeline. Now it's time to execute our build pipeline and watch all these components come together. So we're going to execute our build pipeline by say build now. Let's speed this up with a little movie magic. Now that our execution is finished, let's take a look at the results. Over here under console output, we can see the output of our Jenkins pipeline. We can see that we've performed the pull from get and the various stages that were executed as part of that. Further down, we'll see the Dynatrace Monaco execution with the final statement that the deployment was successful without errors. Here, we'll take a look at our ServiceNow Python execution, which shows our integration to push the SLO values into ServiceNow. Finally, this would be where an application deployment would be. In this case, it's just an SSH put. Now, let's go to Dynatrace and take a look at the SLOs. This is where we'll see that Monaco has created our front-end failure rate SLO. When we expand this, we can see that this SLO is looking at a service called Easy Travel Customer Frontend. And we're looking at the service errors total rate metric provided by that service. Below, we can see the various metrics that are created through this SLO definition. Now that our metrics have been defined, let's go take a look at our metric event anomaly that was created by Monaco. So over here under our metric events, we'll see a metric event anomaly called SLO Easy Travel. Here we're looking at the metric selector that was created by Monaco, and the SLO threshold has been set to 98%. This is the value that was specified in the Monaco configuration. Now when we scroll down, we can see that we've created the SLI specific key, and we've set the value to the SLO front-end failure rate, which we configured within ServiceNow as part of the Monaco configuration. You'll see this in a moment. Within ServiceNow, let's take a look at what our automations have created. We have our service level indicator, which was defined for the Easy Travel service, looking at errors, threshold of 98%, with a useful description and the data processor that was created earlier. In addition, an alert filter has been defined looking for types of SLI and the resource matching the value that we saw earlier in Dynatrace. All of these components were pushed via the automation. In addition to the SLI, our SLOs have been created. Here we can see our Easy Travel front end errors referencing our SLI have all been defined with the time period, the overall objective, our current value, our remaining error budget, and the overall burn rate. Now that we've completed validating our configuration, let's see what happens a few minutes later when our push causes an application-related problem. Let's begin by reviewing the problems within the Dynatrace console. The problem here at the top is called SLO Easy Travel front-end failure rate and is an SLI violation that we have defined within our observability as code capability. Within, we'll see the alerting profile is showing that we've sent this SLI breach to the ServiceNow through the integration defined between the two platforms. Now, let's check in ITOM Event Management. Within the Event Management console, we can see that we've received the event from Dynatrace and processed it as an alert. This alert has been defined as an event type SLI, which is the custom event type we've defined. The resource value has been sent to the SLI identifier based upon the contents of the event, which will be mapped to the correct SLO. In addition, the application service has been properly related to this alert. Checking the SLO table, we can see that our SLO has been impacted and is showing consumption of the air budget due to the open alert. Now, let's review the SRO workspace. Within the Application Services panel, there is our application service Easy Travel, which has been defined and indicates that our open alerts and incidents for it. Inside the application service, reviewing the timeline indicates that there are 2 alerts which were opened within a relatively close period of time. Over in the alerts panel, the alert we were reviewing earlier is listed, as well as an alert from earlier today. Over on the reliability indicators, we see that our SLO is defined and burning down, just like the table we looked at a few moments ago. Thank you for attending today's demo.